Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. It is still Pi Day, and we are honoring Pi Day by playing the awesome Pi song. You know, that song goes on forever. Let's get back to it. The binomial distribution, part 2. Okay, a lot of words here. A lot of words. Bear down. It's not as bad and horrible as it looks. So, we're talking about the binomial probability distribution function. We explored it on the previous video. So we still have an experiment where we have two outcomes, success or failure. Success, if success is p, then failure is 1 minus p. Okay? So, there are n independent trials, and the probability that there are r successes and n minus r failures is the binomial distribution. Isn't that wonderful? Yes, so it's always, if we list it by using the formula, that first one is the success, probability of the success, and the second one is the failure. We call this the binomial probability distribution function, the probability that the random value of x is equal to r successes, a specific number of successes. Again, this represents all of the successes, whether it be 0, 1, 2, 3, 4, or all the way up to n, and r is a specific one of those. The expected or mean outcome, mu, or EX, we already talked about expected values, is equal to the number of trials multiplied by the probability. Okay. Last biggie here, if x is the random variable of a binomial experiment with parameters n, number of trials, and probability p, then we write the random variable x is distributed as a binomial probability distribution function. Now, I don't say that last part. In fact, that's the last time I'll ever say it, and I cannot believe I haven't stammered yet. I'll just say x is distributed as b and p, or whatever. Okay? Good news, boys and girls, our calculator will do the heavy lifting for us here. To find the probability that x equals r, a specific value, this is very important, we will use the binomial probability distribution function. But if we're looking for a range of values, we will use the binomial cumulative distribution function. That's if x is less than a certain number of successes, less than or equal, or greater than or equal to a certain number of successes. Okay, and our calculator does both of those, and I'm about to show you how. Okay, so here we go. 72% of union members are in favor, nice spelling, of a certain change to their conditions of employment. A random sample of 5 members is taken. Find, blah, 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 blah. So 72% would vote yes, basically, which means that 28% would vote no. The probability that 3 members are in favor of the change in conditions. And I'm going to go here, just read B real quick. The probability that at least 3 members are in favor of the change conditions. Specific, range of values. Specific, cumulative. Let's go back to the previous slide. Specific, cumulative. Specific, cumulative. Well, how do we differentiate that on our calculators? Okay, so we have 5 members, our important things. We have 5 members, 72% in favor, so that's the yes, 28% is the no. And we're going to randomly select 3 members. Or no, we're interested in 3 members, sorry. What we're saying is, what we're trying to find here for part A is the probability the random value of x equals 3. For B, we're trying to find the probability that the random value of x is at least 3, so that would be greater than or equal to 3. Okay? And then C is the expected value. We'll get to that in just a second. So, to the calculator. Where does this puppy lie? Menu. Oh, I don't know. Probability. How about distributions? And it's down here. Specific. We're going to use PDF. Specific. Okay. Number of trials. Well, what's the random sample? We took 5 numbers. The probability of success was 72% or 0.72. What number are we interested in? Remember, that was 3 and kapow. So our answer would be 0.293, rounded to 3 sig figs. So let's go back here and we'll say that that's approximately equal to 0.293. What could be easier? Well, how about greater than or equal to 3? Okay, probability greater than or equal to 3. Okay, so this is a little bit tricky. Okay, not a little bit tricky. You just have to do one more thing. So menu, probability, distributions, and now we're going to choose the cumulative one, binomial CDF. Okay, and they ask for more things. Number of trials is 5. Success is 0.72. Lower bound. Okay, well, it said at least 3, so our lower bound is 3. What's our upper bound? Well, our upper bound, we only sampled 5 people, so our upper bound is 5. So it's pretty straightforward. We hit that, and there she blows. Gives it to us right there. 0.862. Isn't life great? So this would be equal to about 0.862. This is wonderful. And part C, the expected number of members in the sample that are in favor of the change. Well, the expected value, EX, and I should have put it, I believe it's on your formula sheet, is equal to, it is, did I put it here? I don't think I did, sorry. Expected value X is equal to NP, yes, very simple, which is equal to the number of trials, or which would be 5 in this case. It's 5 members taken, so each of them counts as a quote-unquote trial, times the probability of success. I said sex and then I panicked, I'm sorry. And I was trying to say success. Okay, 5 times 0.72, so that would be about 3.6 members. I know you can't have 3.6 members. You don't round it, you just leave it like that. Okay. All right, I have done all the damage I can do here for these examples. Let's check back in on Pi, see how she's doing. That will be our sign off. We will have one more short video. I am out.